Alright, today we're going to talk a little bit about tube bias. So what is tube bias? Well, in brief, it is basically ensuring that the tubes are under the right operating conditions to allow the amp to perform as efficiently as possible and as safely as possible, and it also affects your tone and your output. So we look at a couple of metrics, mostly plate dissipation and plate current. Now on any tube chart, I'll put one up here in the upper right hand corner so you can see. We can see some operating conditions for each tube. The 5E3 has 6V6 tubes and its max plate dissipation is 14 watts. So 14 watts is max, and a good rule is to have your plate dissipation at 70%, and I think that's at 9.6 or something like that. Probably not roughly. So you would want to see a plate dissipation for both of your tubes at 9.6, and that means they're not drawing too much current. Recently, I found out that the transformer, if you've seen my other video, I'll put a card up here, that the transformer replacement that I did on this 5E3 caused the bias to change significantly. I went from, okay operating conditions, almost ideal operating conditions, to not dangerous, but one was at the max 14 watts and the other one was at 17 watts plate dissipation. So what I had to do was change the cathode resistor. Now, in a simple amp like the 5E3, you've got a cathode resistor, and the value of that cathode resistor, and I'll put an image in the upper right hand corner here, the value of that cathode resistor determines your plate current, plate dissipation, plate voltage, etc. The drawback that I see is that you have to keep putting resistors in and out, or using alligator clips. When using your measurements, it is a little bit dangerous, and you don't want alligator clips, hanging off of your turrets. One slip of the turret or one slip of the alligator clip could cause a short. What I've thought of is to create a adjustable bias system. Now, this adjustable bias system applies to cathode biased amps only. We'll make sure that it never goes too low or too high. We'll just have a potentiometer to go between the sweet spots. Alright, so how do we fix this issue of having to continue to replace this 250 ohm resistor? Well, in my case, I need to replace it with about 500 ohms minimum, because my transformer has such a high voltage. What I'm going to do is actually add two resistors and another turret. Alright, and this first resistor here is going to be my 500 ohm minimum. Okay, this will always be here. No matter how I adjust it, 500 is always going to be the bottom. In this area here, I'm going to have my adjustable resistor. Here will be another 500 ohm resistor, and I'll be in parallel with a 1K resistor. When I'm in parallel, I'll get 333 ohms maximum. So when this potentiometer is turned all the way to the max, I get 333 ohms added to the already existing 500 ohms. When I turn the pot all the way down, I get 0 ohms, and my 500 bottom remains. So this allows me to adjust between 500 ohms and 833 ohms. Right in that sweet spot area, so I don't bias too low or too high, but I still have a range so that I can adjust for specific tubes. Alright, the first thing I've done is I put a potentiometer in here, and I had to drill through the chassis, which was really difficult. As you can see, it's all marred up. I'm not very happy with it, but this will be underneath the amp in the cabinet, so I'm not too concerned. Now, here's my first. This is the closest I had to 500, and then I've got a 468 somewhere. So in total, they'll equal about 1000 ohms, or 1K. Alright, so you'll notice I put another turret here. I just glued it in, and I've still got my cathode bypass cap right here, so that's uninterrupted. And instead of stretching this 549 across all the way, we're going to put it in series with another 500 or close to 500 watt resistor. So that'll go there, and that will be our fail-safe as discussed. And then a potentiometer will be connected from here to here, and that will adjust the value. Alright, so if you were happy with your 250 ohms and it's giving you good plate dissipation, you might want to make it a little hotter or a little colder. You could put a 200 ohm resistor right here perhaps, or stick with the 250, whatever you want your bottom minimum to be. So the first thing we're going to do is add some wires to the potentiometer right here, and then we're going to put in our other resistor in series right there. Alright, so there's our pot. Then we'll solder it in. Good. Then we're going to take the other end of that wire and just try to get it in here as best we can. There it goes. Alright, I put my other end of the wire there. Now we're going to take this resistor and put it in between this point and this point. Alright, so this worked in my head real well, so let's see what we got here. Look at that. I can tune it just like that. It's very sensitive though. I don't know if, wow, it's sensitive, but it does work. Alright, I was able to get it at 575, which should be perfect for this amp, so I'm going to go ahead and calculate the bias. Just to test it, I found that the plate dissipation was affected by the potentiometer, just as predicted. However, the potentiometer is, and this is plate dissipation after I cranked it up to near max, 900 ohms. This is more in the 600 range. So I just need to get a 1K potentiometer, and so I have a very gradual build-up, not so exponential. I'm going to replace this pot with a 1K pot and then see how our resistance is. Right now, the pot is way too sensitive. I'll show you what I mean. 609 ohms. Now watch what happens when I just tap. I'm just tapping the pot. I mean, look, I just dramatically changed the bias based on tapping the pot. So, back to 600. So yeah, and it really does affect the bias just by tapping. So I'm hoping this lower value potentiometer will fix the issue. Let's see. Yeah, basically 1K. Always remember to take that little tab unless you're using it. Alright, this one works much better. Look at that. Tapping it, tapping it, tapping it. It's not as sensitive. I can dial in the exact ohms that I want. Pot is now in. Now let's take some measurements. Alright, we got it set on 650 ohms. Now let's check the bias. Alright, here are our metrics. We have resistance, plate voltage, voltage drop, plate current, and plate dissipation. Alright, so in order to get our resistance for each tube, we're going to go put one lead on pin 8 and one lead on pin 3. Pin 3 is the plate, and pin 8 is our output transformer center tap. So we're going to find the resistance between those 2 points. It happens to be 495, so I'm going to write that down, and that is for the right tube. Now in order to get my plate resistance for the other, I take off my red lead here, put it on pin 3, of the next tube, and I get 602. Alright, so now that I've got my resistance, it's time to do the most dangerous thing and get the voltage drop. Okay, so in order to get the voltage drop for each tube, I keep my contacts where they are. My leads are hooked up on pin 3 and pin 8. Again, this does not pertain to every tube amp. This is just for this particular one that runs the 5Y3 and the 6V6 GTs. It may not be applicable to any other tube amp. That's very important to say. Let us go ahead and fire it up, get our voltage drop. Goes without saying, always do this with a current limiter. Always have a speaker plugged into your amplifier when it is on. It must have a load at all times. We're on volts DC. And any moment now we should get a reading. Oh, 17. Okay, 17, fair enough. I'm going to turn off the amp. Next thing I'm going to do is take my filter cap drainer. We are going to unplug the amp. It goes without saying, before you begin this procedure, have your filter caps drained. Hold it there for about 20 seconds each, and then we'll be good to go. Alright, now that our amp is drained, the filter caps are drained, we leave the amp unplugged, and we take our red lead and put it to pin 3 here. Get on. We will measure the voltage drop. I will plug the amp back into the current limiter. I will then switch it on. 10. Alright, so we'll write down 10. Alright, we'll turn the amp off. Unplug the amp. Drain the filter capacitors once more. Because there's one more. There's one more that we're gonna have to take. For the next one, we take our black lead off of pin 8 and we attach it to ground, which would be easiest, would be the chassis. Now I'm going to keep my lead there on the right tube, and we're going to go ahead and plug the amp in and turn it on. This is the high voltage. It'll start off very high. And alright. Right one's going to be about 428. Okay, we turn off the amp, unplug the amp, drain our filter caps. After draining the filter caps, I will undo my red lead and put it on the other pin, on pin 3 on the other tube, and ensure there's a secure connection. I will now plug the amp into the current limiter. Prepare to turn on the amp. It's like 422 is going to be our number here. So we're going to turn off our amp now. I'm going to unplug the amp. Going to drain my filter capacitors since I'll be handling it in a minute to take the leads out. One thing I forgot to mention is you always drain your filter capacitors at the positive side. That's where the voltage is. This is ground over here. Alright, so it's time to get the calculator, perform our simple arithmetic. Voltage drop divided by resistance. So this will be 17 divided by 602. 0.02823. 28 milliamps, I think. Alright, now it's 10 divided by 495 for the other one, and that is 0.02020, so 20 milliamps. Alright, now we take this number and divide it by this number, or sorry, multiply it by this number, 0.02823 times 422 equals 11.9. And let's see, this one here is 428 times 0.02020 is 8.6. So these tubes are obviously not matched. The maximum plate dissipation for 6v6 GT is 14 watts times 70% is 9.8. So 9.8 would be our ideal plate dissipation. So the average of 11.9 plus 8.6 divided by 2. So the average of these two is about 10.25. So that's not too bad. So we'll keep it like that for now until we put those new old stock tubes in and see how they are. They are not matched either. Now, a wise man once said, Uncle Doug said on his channel, and I hope I'm not misquoting him, that at times unmatched tubes can give more complex harmonic distortion and maybe more pleasing to the ear. As subjective as that is, it's it's something that I could definitely see being true for guitar amplifiers. So you obviously don't want tubes that have a huge disparity, but when you have tubes with this percentage of disparity, it's not really that big of a deal. So to conclude, that's where we'll keep the bias for now. Thanks for watching.